Hi there. I made this presentation in order to showcase what I've been building for the last 2 years. The idea first started as a master's thesis at UCLA, but has since turned into a passion project with potential commercial payoff. The idea is to forecast NBA games by building a model based on low level data in the hopes of capturing elements of basketball dynamics that are lost in higher level abstractions. The ambition of this project is to outperform the sports betting market. However, the strategies to succeed really goes beyond just a good model. Around the model needs to be a system that is able to acquire and manage new information. The approach I want to take with this presentation is from a developer's perspective, since the main purpose here is to give potential employers some reasons why I might make a good data analyst or data scientist. So I thought it might be more beneficial to talk about what is under the hood before we look at the current data product. Ballwiz is a full stack development that is mainly composed of Python and R code. Most of the Python code lives under a Flask web framework and the R code inside an R package. They're all version controlled by Git with Bitbucket and ran on Amazon's web services. What you see here is the Ballwiz blueprint. There's a lot going on here, but it is basically made to perform four major functions, which I will go through one at a time. The first is the static data gathering. The Ballwiz model analyzes low-level play-by-play data, and instead of buying curated data from vendors, the program scrapes it from news websites and wrangles the data itself. This ensures that raw data can be obtained as soon as it's available, and that no information is lost in the process. The data is then stored either as a text file in a file system or in a database. The second is dynamic data gathering. Aside from scraping web pages, data can be obtained through API providers. Information such as betting lines and pricing, player injury, and trade news are always changing and require monitoring around the clock. The solution to this problem is the setup you see here. Worker scripts responsible for each API send new data points to the messenger queue. Where more worker scripts subscribe to the queue will write to the database. A Tornado server also subscribes to the queue and relays the data via WebSocket to other applications that might be interested. There are many benefits to this setup. Any script can break without compromising any other part of the information flow, which makes it very robust. Information are persistently stored and delivered real-time. Debugging is also easier given the isolation of duties to each script. The third is the analytics server. The research and building of the model happens here. The server has access to the private Ballwiz R package, as well as the database, data objects, and data files. Tools such as RStudio and IPython notebooks are accessible via the web browser. A small Flask server can handle requests from other applications. The server uses the C4 class of Amazon instances, which is adequate in handling recursive calculations and simulations. The setup makes it easy to conduct research, build and rebuild mockups, perform heavy computing, share results, and repeat. The unique setup design has the upsides that are most suitable for my particular needs, and perhaps only more practical when dealing with few number of users and relatively small datasets. Regardless of this, the computing resources could be quite expensive in the long run. That's why I've designed it to be able to be turned off with no effect to any other part of the system. The fourth and last is the web server. Nginx is the primary server that allows multiple servers to come under one roof to deliver a unified control panel. It is styled by Bootstrap and utilizes JavaScript libraries such as Highchart and data tables. It is time to take a tour through the data product. This is the main page of the Ballwiz control panel. On the right, it gives some quick overview of current model performance, pending wages, and historical performance. The project had a very promising start this year, but since Christmas, it just collapsed. My suspicion is that the parameter that dictates how quickly the model adjusts to new data is just too low. There were a few teams that began to continuously underperform compared to the start of the season. The market quickly adjusted. I did not. This is a tough problem as the static sensitivity setting that I thought was optimal might be subject to change over time. Anyways, back to the tour. On the left here are a list of games that are now available on the market. Let's check out the Minnesota-Cleveland game that's happening 14 minutes from now. The chart here is the historical pricing of this matchup. As you can see, market prices change throughout the day. And if applicable, a pin of player news will be placed on the timeline the moment it was captured. Thanks to the Tornado server, we're able to receive new pricing data points asynchronously without having to refresh the page. At the bottom are the bet slips. It is connected to the API of one of our aligned sportsbook. It shows all current market price for the event, and it also updates asynchronously. The next stop is a newsroom, where news regarding all active NBA players are aggregated and presented. The table on the left are tweets from our dynamic data gathering from about 120 sources on Twitter. And thanks to the JavaScript library data table, we can search through this relatively easily. On the right, we have the RSS feed from a reliable source of player availability, RollerWorld. So what you just saw are some of the features that help us manage the changing information in the marketplace. Next, I want to talk a bit about the model. There are 30 teams and about 430 active players in the NBA. That's a lot of information changing from day to day during the season. Although the program automatically chooses most parameters based on cross-validation errors, it is still a good idea to monitor data activities and pick up on any unexpected occurrences and figure out what is going on. From here, we can choose an NBA team and choose what players are expected to be available for the upcoming game. The graphic on the right is very helpful in seeing what players have been missing and the impact it has on the usage of other players. The method of estimation can vary. For example, a player's playing time and usage is a function of the availability of other players. It is also a function of coaching decisions that can change over time. Knowing that, the proper modeling method is a detrended regression with teammates as factors. The fitted line we see here is the one step ahead extrapolation of the model, and it generally works pretty well. For other aspects of the model, the difficulty level increases, as the possible factors in play are much greater. My current method of choice is decomposition. The data is broken down by various fits until it is decomposed down to what is generally just regarded as independently and identically distributed white noise. Home court advantage is a well-known factor in the basketball world. So its effects can be extracted, where the resulting errors will be the data points for another fit, and so forth. The results of these models are numeric estimations of probability matrices that is to be used by a simulation engine, and I'll demonstrate how that works. This is the simulation room. The idea is to play out simulated basketball games using model estimations as the underlying set of probabilities. The long-run average result is then our projection for the game. The browser makes a request to the analytics server to begin simulation one trial at a time. The result of each trial is tossed back asynchronously to the browser and aggregated until the desired number of trials has been completed. At this speed, it will take about 13 minutes for 5,000 repeated trials. Since running these trials on parallel, on a C4XXL instance can be about 10 times faster, this is actually not the preferred way to simulate a game. However, it does allow a quick glimpse into what to expect and a fun time while watching. And this concludes the Ballwiz demo, and thank you for watching.